Hello, I'm Floyd Smith with Unravel Data, and I'm here to introduce us to the Self-Service Data Roadmap. This is the fourth in a series, and we are finishing up with this session, and attendance has been really strong. So thank you very much, everyone who's attended this one and all of the four. And the earlier three sessions are available here on Bright Talk, so you can take in the whole series if you've missed any. And each of these webinars is complete in and of itself. And this is actually we're excited to get to stage 4. Sometimes the end kind of tails off, but for us, it's the most exciting part because it's operationalized. And although Sandeep, and I'm sure most of you on this, like myself and others, have been involved at various stages. You know, we've done things that fit into various stages of the silos that Sandeep will be talking about today. This is the one where our Unravel Data does its work. Most of its work is in Operationalize. We won't be talking about that very much. A little bit at the end. This really is general for everyone. We're talking about how to do this kind of project. And just to add to that, not about the particular product, just to add to that, this is Fractal. So Sandeep is a big thinker, and he presents this as how to take your whole darn company, and he's thinking Fortune 500 Global 2000 company, or another large company or an ambitious startup, and make everything in that company self-service. But the same approach works for individual projects and for divisional projects. And so, or you can be doing part of this and use it for that part and then scale it over time to the entire data estate and the entire company. So there's a lot of different ways to use this information. That's been part of the fun of it, is having a new way to look at really everything that we do as part of data teams and people in the industry. So I'm going to let Sandeep introduce himself. I'll introduce myself, talk a bit about the book, and then we'll dive into the core content here. Sandeep?
Hey everyone, really excited to be here for the fourth of this webinar series. So I'm Sandeep. I have been in the data space for more than 20 years, been on both the sides, building products as well as running really data platforms for analytics and machine learning. Obviously, what we're going to talk about is lessons and learnings from my experience, operating at the extremes of scale, different kinds of application supports when it comes to analytics, a lot in the ML space as well. So I'm excited as we get started with this.
Yes, and I'm Floyd Smith, and I'm in charge of product marketing for Unravel Data. But, longtime technologist, been involved in a number of different companies of all sizes, from Apple and HSBC at the high end to the smallest, scrappiest startup, three people with a CD with their code burned on it, So gotten to work at a lot of different levels. And having an event like this where we talk about a big picture, and it's free of a particular project, but actually talk about an architecture for all projects, is a lot of fun, as I was mentioning, and it's an exciting thing to be involved in. So without further ado, let me start by talking about the book. Since Sandeep's the author, I'll handle the intro of the book itself, and then Sandeep will talk about the particular topic. So the Self-Service Data Roadmap is an O'Reilly Animal book, which is their prestige line of either deep thought or very deep hands-on technical stuff, often by the people who invented, are the authors of, or are lead practitioners of big open source projects, different products, and different approaches to doing our work. And that's the latter category here. And as the book describes, it'll take you right through building a self-service data portal, a self-service portal for all of your data-related work, again, right up to the company level. And you can also do it as a proof of concept with a particular project and then scale up. So a lot of different ways to use this. It's worth looking through, it's worth paging through, it's worth reading in depth, it's worth using to drive Asana or another project management tool to set out everything you have to do. And what we've done in this series of webinars is we've taken the 4 parts of the book. There are 18 hands-on chapters, like do something chapters in the book, and they're divided into 4 silos. And we've hit each of the previous 3 silos, and now we're going to do the 4th one, as you'll soon see. So this is work that'll it's live now, but it's work that'll hang around for a while, and I think people will be using these webinars and the book and using this as a framework for a lot of important work, and I'm excited about that. So let me turn it over to Sandeep again to take us into this part of the series.
Thanks, Floyd. So folks, before I sort of talk about the 4th phase in this overall journey, I'll just spend 2 minutes, giving you a brief background on the motivation of this book, because this will help you internalize how to leverage this book, right? So as a data leader, there were 2 aspects which, I was observing. And, this is again, through my different years of experience in different companies. The first aspect is when you think about the whole value creation from data. Data by itself is useless until you can generate value, right? And the value created from data, any project, be it developing a dashboard, be it having a ML model, be it a simple lookup of values which the marketing or the product management team or the sales customer support team can look up for better in what they are doing. It all boils down to 4 stages, right? Any project starts with discovery, followed by data discovery in terms of figuring out where the data sets are, what they are, then the data preparation. I have never seen data which is in a perfect state. So there's data cleaning, data extrapolation, validation. Then you get into the build part, where you then start building up your basic matrix, basic, what you can think about are pipelines to convert the raw data into different layers. Typically, any consumption side builds on multiple kinds of layers that are built on the raw data. And then the final part after build is now you have this pipeline that you want to deliver in your day-to-day operations. And that is where operationalize becomes the 4th phase, right? So one aspect or the one motivation of this book really was breaking this down into 4 stages. And then within each stage, there are specific milestones to achieve. You can make this a tangible problem. So, instead of just thinking of the data platform does not work, it's not meeting our needs, it's too slow, right? Next time you hear comments like that as a data leader, one of the suggestions I will give you is really break this down. And this is what the book, origin of the book was. End of the day, there are 18 KPIs. You can obviously make it more fine-grained, you can make it less fine, but this is based on my experience. You can break it down and really then start drilling into which part, which KPI is the slowdown. Right? And the way you could potentially leverage this is really sitting down, like both as the platform team as well as the data users in the form of data scientists, analysts, marketers, to understand, if you're trying to build something out, what takes the most amount of time. So this is the whole, I would say, the linchpin of the book, which is time to insight is the time it takes to go from raw data to the insight. And insight could be anything, like we talked about. And this time to it down as a sum of these 18 KPIs, right? Time to find, time to interpret, time to move. And every organization I have spoken, right? When you look at these 18 boxes, if we were to color code them, as green, red, yellow, right? Every organization will have a different set of these boxes that will be color coded. So if you're a relatively small organization born in the cloud, right, things like time to find essentially becomes very, very simple, or it's not going to be a problem for you because you will have a small number of very large tables. So if you look at any of the Web 2.0 companies out there, that's what they have. They have a finite set of tables which are very large, run in petabytes. But if you're been in the business for 10 plus years, and if you're coming at it from a lot of data accumulated over a lot of versions, on-prem software, in-cloud software, you're trying to find would be the biggest red box here. So hopefully you get the picture. Every organization is different, and I think of it as people, process, technology, right? So depending on what the skill sets are, what your current data is, and what you currently have, these boxes will have a different significance for you. Today we are going to specifically focus on the operationalize. So the other three webinars have covered discover, prep, and build. Today it's going to be the operationalize phase, right? And the other insight here is this is the part where I would say a lot of time is spent. When you think about the rollout process, obviously the first three phases make or break the project. But really the last phase is where it becomes more of the common case, because now the pipelines are running daily at whatever the frequency is, right? So with this aspect, I think the second learning really is operationalize is, I would say, the Achilles heel of any data team. Now, within operations, just to tee up the different buckets there, the key points that come in when you think about operationalize is the very first one, which is time to optimize. In fact, I'll tee up here and then I'll go to the next slide. So time to optimize is all about, see, any query can be run, any pipeline can be run. The question is, will it scale, right? Will I get an out-of-memory error when I try to run the query and try to do a join on a billion-row table, right? Once you have optimization in place in terms of looking, and we'll talk a little bit more about some of these pieces, then it becomes more in terms of how well can I orchestrate. Orchestrate is all about scheduling, right? What is the right approach to schedule so that there is limited attention, right? Your SLAs will be met better. So that's all about how to time to orchestrate. Time to deploy in specifically for machine learning models. So when you're operationalizing machine learning models, how do you build up and have this continuous training, assuming you have an online model? So deploy is primarily, I would say some of the challenges happen when your insights are more ML based, right? There's a special handling required. The next one is quality. No pipeline is perfect all the time, and you need a constant way to track quality. Right? And the last piece here, which is now become extremely important across pretty much all organizations, is optimizing cost. Because the moment you think about running in the cloud, one of the things, the sticker shock would be the linear cost model. Pay as you go suddenly becomes a nightmare, because now there's really no bounds in terms of amount of money that can be spent, and there are a lot of battle scars within that context. Right? So just to recap, in operationalize bucket, when you think about how to make operationalize easy, right, or self-service, or to really democratize it, because the goal here is it is not just one team that is responsible for operationalize. In fact, data is a team sport. And unfortunately, many organizations, instead of team sport, it becomes more of a, passing the buck or throwing the ball over the wall kind of a model where, after the query is built, now to run this query in production, right, there would basically be some ETL engineer or some ETL team that will now start analyzing the query, right? Now, guess what? that team, the ETL team, has very limited understanding of the business domain logic, right? They are specialists in the ETL side in distributed systems. They know how to write Spark programs effectively, but they may have very limited understanding of what the data set is, what the query is trying to accomplish, right? And this is an example where the reason you need to think self-service is to remove these friction points instead of going to and fro. Like, just from my personal experience, the way this story plays out is, a data scientist, analyst would typically out a query. They would build it more with a small sample. They'll try it out 100 rows or 1,000 rows and say, yep, this works. I'm getting the matrix. This is correct. Now let's operationalize it. Right? And this is the time when that query now in reality has to run on extremely large tables, or there can be extremely large data SKUs. Right? And that transformation, a query or Spark code, may not really stand the harsh of production data. You may get out of errors. The query for hours and hours will be very poorly written, and this is where there'll be that to and fro that will start. So the whole intent here is, by focusing on some of these services and making them available, you can reduce this to and fro, make it a team sport. And what that basically means is a data user should be able to get notified. Okay, my poorly written, and I need to improve my query because the data layout is bad, the SQL I'm using is bad, maybe I'm using inner joins, maybe I'm using a pretty bad combination of some of the well-known heuristics. Maybe the data layout, right, the way data needs to be accessed, the partitioning can be done better, data indexing can be done better. There are lots of things, right? So with that essence, as we think about operationalized services, those things I mentioned earlier, time to orchestrate, think of them as services that you need to build out. So if you're thinking of a platform, does your platform has something for query optimization? Does platform has something for pipeline orchestration, model deployment, quality observability, cost management, right? And once you figure out, okay, these are things you need. I can tell you that if you're running a platform without these services, it's just a matter of time where your time to insight will get impacted. Some projects will really slow down because these services are like the bread and butter. And then once you have something in place, really thinking about crawl, walk, run. In fact, the entire book talks about it as a Maslow's hierarchy of needs, right? Basically, for each service, how do you is the service there? Can the service be used by data users? Can data users directly leverage rather than having to go to and fro or moving the ball around? Can they accomplish these things, right? So with that context, I'm going to now double click more on the query optimization service, right? Because we'll have time only really to one of these. Each of these in the book are chapters. So every chapter pretty much follows a similar structure. Now, when you think about the whole aspect of query optimization, right? It really boils down to completion, faster completion, and meeting SLAs, right? Because, like I said, anyone can write a query. Anyone can build a toy pipeline. In fact, a lot of times you hear high school kids, middle school kids able to run the basic, because these days there are a lot of these building blocks available. But guess what? That works if it's a toy, right? Hello world, right? But when you're running in production, thousands of pipelines daily, which have time critical. If it's a risk or a fraud detection pipeline, it has to come time. If you miss the time SLA, you can imagine the impact the business can have. So, optimization focuses on, okay, how do I get faster completion and stricter SLAs? How do I better risk utilization? And how do we get to performance isolation, right? Those are some of the key aspects in play here. Now, query optimization by itself can be thought about as quite a few different aspects to it, right? And I was briefly touching on these. Your Big Bang essentially comes by the physical data layout, followed by index and view recommendations, followed by tuning. Especially one of the biggest things we see is even if you have written the query, let's say you have written a Spark job, right? Or a Hive query, or pretty much something running in Google BigQuery, right? There are often times in terms of what have you chosen. Now, obviously, serverless has lesser knobs available, but if I think of traditional Spark, number of mappers, reducers, vcores, memory, these are all parameters. The defaults are is something that most people run with, and defaults don't work for many scenarios, right? So knob tuning, and then obviously it's plan optimization. Can there be a better sequel? Can there be a different way to write this? Write what you have been implementing. Right? Um, Now, when you think about these services, how do these services operate? Right? Again, it's not magic. Basically, there are different. Firstly, there are different knobs, right? Knobs at the resource level, knobs at the platform level, things like container settings, execution codes, knobs at the job level, right? So tuning is all about, or optimization is all about, what knobs do I need to modify, right? And I think one thing doesn't show here, SQL by itself. So within the job, the actual SQL or the actual program that you've written, right? So that's those are all aspects in the job. Just wanted to really highlight that. And these knobs that exist, right? It really is mapping down into accomplishing three tasks, right? Because for any kind of optimization service, you need to aggregate the stats, because you need to collect what's the utilization, how is the job doing, how much time is going, waiting for the executor, right? How much time are the workers spending? How well utilized the container utilization is, right? So aggregating tasks, aggregating stats. Second is analyzing stats, right? Which is, okay, what do these mean? How do they come together? And then really optimizing jobs. So if these three things are done, the triangle you see on the left-hand side is really what is done by the platform team that has an expertise in, under the covers, queries work, right? What exactly happens? Just to give an example, this is where when I've been running teams, you hire people with speciality in different query engines. So, like for instance, you'll have someone who is expert, someone who is a Hive expert, someone who is a Presto expert. Just because each of these query engines, again, like someone can pick, same person can pick up all, but typically you need that expertise, right? Uh, and this is where, if you built it out as a service, right? Some of the big Web 2.0 companies have some kinds of these services. There are some open source projects out there, like Dr. Elephant, if you guys are familiar with that, right? That kind of provides this. This is where Unravel comes in as well. This Unravel's core strength in terms of ability to truly take all these aspects and really build out refer to as the combination of insights. And again, this slide is not Unravel specific. This is really what a service should. You can put together the service yourself by string. I have seen some companies that have written this completely from scratch, from aggregation to analyzing with basics and then optimizing the jobs. It's like encoding the knowledge of the expert, right? This is an example here, right? Which is, if you think of an open source equivalent of what some of these services basically do, right? Now, when you think about something like Dr. Elephant, it is basically a heuristic. It's a combination of rules. So to give you an example here, it's trying to basically figure out, the threshold values in terms of, the size of container memory, right? And this is an actual example, and they'll pretty much have a collection of these examples that are out there, right? When you think of these services, you might be thinking, hey, it's just a collection of rules that have been written, right? And these rules then decide whether I need to change a knob, add more memory, change my SQL, change my data layout. That is actually not the case. In fact, this space of query optimization, and this is the key that would be helpful for you to understand, is it has evolved. In fact, there's lots and lots of research in this space. Just to sort of give you an example, my our co-founder at Unravel, Dr. Shivnath Babu, went to Stanford at Duke. He has in fact written multiple papers on this topic, right? Where the rule-based version, the kind of simple example I showed, heuristics, right? That was a very starting point, right? Then over the years, over research, people started building cost models, so cost optimization. In fact, some of the query optimization in enterprise databases uses cost models internally, right? So there's a cost model approach. Just to sort of jump through in the interest of time, under the covers, it is a combination of experiment, simulation-driven, adaptive modeling, machine learning, right? So to give you an example, the area has evolved significantly, right? To the extent where it is not just simple heuristics, right? Like what we saw in the earlier open source example, but something advanced in terms of machine learning. And over here, just to give you an example of what machine learning here would mean, within Unravel, the Unravel product actually uses reinforcement learning, right? And what learning means, for those of you already familiar, but just to sort of level set here, is you're learning from the environment, right? So when you think of different forms of learning, supervised, unsupervised, reinforcement learning is the best kind of learning, where you know the knobs. There's obviously some combination of models for those knobs or rules for those knobs, but then the actual values of those knobs can be learned and can be different for every environment, right? So I would, just we are short on time here, but really encourage you to think about, when you are exploring optimization services, right? This area has come a long way, right? And in some sense, this is where the power of AI is becoming more and more visible, especially if you think of your own situation as running a data team with multiple data users. One of the biggest challenge has been, in fact, just working with customers. We have worked with customers where they have 2,000, 3,000 data users that are using the platform, and each user is writing their queries, right? So imagine what that, each of those queries, getting them right, optimizing them, making them accurate, it is not humanly possible. And this is where having a service tremendously, adds, like I said, going back to the performance SLAs, I've seen nightmares without having the, like the kind of SLA guarantee that you would get. And also, this slows down, right? Without this service, the ball, it'll just be a ping pong ball. A data user will write an initial basic, like I would say, build out a basic prototype, but then not really know what needs to be optimized, what they need to do. So this is where the service really plays out. Right? Now, just to extend, and I can go on and on. I think this each of these topics are very, very deep. In fact, really encourage any follow-up questions. Specifically as you go through the specifics, right? I wanted to maybe take a step back and build the overall perspective, right, as to how you need to think about all the steps that we've seen so far, right? And one way to visualize it or obviously the way I was talking about was any project has 4 phases in it, right? The discover, prep, build, and operationalize, right? Now, in reality, it is a loop, right? Because once you operationalize, it's not that things are done. Operationalize, there will be changes that will happen to your ETL. There will be data transformation, data attributes that will get changed, semantics will get changed. You may discover a whole different, I would say, new data set, and may want to update your models. So in reality, what exists is what we like to call as the data ops infinity loop, right? And as you look at this loop, right, if you start looking at any of the arrows, plan, create, orchestrate, test and fix, continuous integration, deploy, operate, monitor, optimize, feedback, and so on, right? Now again, this is a loop which is similar to any software development. Right? This is not you can pretty much think of any software development, and data really is code. And the data pipelines, we need to apply the same rigor, right? So within this context, I think the high level bit really is about how you can make the phases self-service, right? Because it's a team sport. Data engineers, data analysts, data scientists, CDOs, and I would say citizen data users. That category, you will have marketers, product managers, sales, customer support. They all need to work together in terms of this loop, the different phases of this loop. So I just basically want to take a pause here. Floyd, other aspects you want to bring up here before we talk further?
There we go. I unmuted myself successfully. Thank you for asking this. Let me take us back to a couple of things to mention. First, I'm taking us back to the initial overview slide. I want to start by pointing out the value of this slide in project management, stakeholder meetings, progress reporting, and so on. I'm going to have a question about this to ask you in a second, but we all know that in most projects, there's a rush to operationalize whatever that's called in the given project, right? Everyone wants it done fast. This loop, it also helps because someone will say the absolute key to self-service data projects is cleaning the data. And someone else will say the absolute key to these projects is A/B testing different ways to do it. And others will say, yes, well, what about getting the query processing correct, And in a sense, they're all right because your project can founder on any of those. What this single chart is great for is helping keep everything in perspective and showing that everything has a time and a place. So that's the main point that I wanted to make, and to, the level of generality and specificity that you've used here, I know comes from a lot of experience. So although you may fine tune this yourself, or maybe for a smaller project, you aggregate some things, don't expose them. There is a reason that this is divided into these 18 services. So take a look at the book. If you're gonna go into a project like this, even if it's less than a company level project, take a look through the book and understand, if you want to shortcut it, understand how you're, excuse me for being blunt, but how you're going to get away with that. And if something's taking a lot of time, look at the big picture and see that there's a lot going on. Have you seen issues, Sandeep, with people trying to rush through this and not hit all of the marks that you've set out here?
Yeah, so the biggest issue I've seen, Floyd, is what I refer to as boiling the ocean, right? So until you put this together, right, in a view, what typically happens is that there is a flavor of the month or the flavor of the week problem, right? And essentially, it's like you think about blind men and the elephant, right? You touch on different parts of the element. It's a trunk, it's a tail. So similarly, end of the day, you're dealing with an elephant. So this picture is a picture of an elephant, right? And what happens is most teams just stumble on different parts of the elephant, and then that becomes the flavor of the month. Oh, time to train is horrible. Let's really focus. It goes on for a month, and until it fades out because you've suddenly realized that your time to optimize is just not working. All data engineers are typically a very small team of data engineers, about 15 or 20, trying to support 50 to 100 data users. They'll be like, okay, forget about all that. Let's just focus on time to optimize. How do we reduce that? So I would say that is one problem. And obviously the second problem is trying to do everything at the same time. I've seen this amazing, ambitious offsite meetings where we spend one day, say, okay, let's pick each and every box, let's invest. Guess what? When you focus on everything, you focus on nothing, right? So this really is about being laser focused. That yes, you will have different parts of our house burning, right? The key is to pick the most important box for a quarter, and typically my strategy is take two boxes. You cannot one and maximum two. Give a quarter and have clear success criterias, clear tangible value. So if we are doing time to optimize, right, we'll start off by, okay, in the last 5 projects, let's analyze where the time was spent, right? And then really focus on, let's move the needle so that at least the areas we know we are spending time, are there tools out there? Can we build something out, thing in place? And that's the thing. And the next quarter, it would be a different set of box. So I would really say that is the biggest problem I've seen, which is trying to boil the ocean, people just trying to do everything, and not really having that focus and moving the needle on any of these boxes.
I'm just going to quickly answer a specific question and then go into another general one. So there will definitely be a recording of the presentation. That's one of the great things about Bright Talk. The moment a presentation is over, it's available for viewing in the same place where you went to join it in the first place. And you can share that URL with other people. I just saw a great presentation. You should look at it. And the URL works 1 minute after this is over, or sooner than that. So that's one of the nice things about this platform. And the question about the cost of the book, I just looked it up on Amazon, and it's right around $40 US. And I don't know how much it costs in other countries. So you'll have to check. If you go to the O'Reilly page for the book, and I'll put that URL up in a second, the O'Reilly page for the book points to a couple of different places you can buy it. And you can buy it online or in print as well, depending on where you're at. So that's, yes, it's quite accessible and again, quite valuable. It can be quite helpful in a meeting to pull a book out and say, well, the experts say, such and such, can help solve some of the easier points so you can get to the tough stuff. But speaking of tough stuff, that brings up a question, Sandeep, that I'm wondering about. This is almost like gossip for tech people, but do you have an example of a big problem that came up at the time to optimize phase or in the operationalized silo, and how it got resolved?
Yeah, gosh, I can go on. With, yeah, absolutely. So, like I said, when you think of this loop or when you think of this structure, a lot of time the teams will be spending on the operationalize phase. Again, not to say the other 3 phases. Without the other 3 phases, you'll not get to operationalize. So let's just put it that way, right? I've seen projects just die on the vine. Just in the discover phase itself, 8 months gone, 10 months gone, couldn't get to the data set. So you put the project on ice and potentially come back to it. I think in the operationalize phase, just to pick one example, and this is one of those where typically, and again, just to abstract the details out, we have seen a lot of critical pipelines, these pipelines that are business critical. So several of the SLA bound pipelines, be it a dashboard that was, that was something that was critical for the business, something that had to be completed by 6 a.m. every day, right? To risk and fraud detection, to critical ML models being refreshed, because these ML models were making predictions, offerings to the customers using the SaaS product. Where we have seen things going wrong is that these pipelines, when they miss the time to optimize or the optimization phase, these pipelines tend to be very fragile. So I have been in so many firefights. Pretty much every day you wake up and you have a high severity issue going on, right? It's one pipeline versus the other pipeline versus something else, like especially when you have hundreds and thousands, right? So the key lesson, and when you then start looking into it, obviously when you're under pressure trying to optimize, you tend to make more mistakes, and anyway you'll just put a band-aid. So there was a phase when we were just putting band-aids over band-aids over band-aids every time something was slipping off, till until you finally realize that, look, this is an important phase. You cannot launch something without having that kind of, I would say, assurance and guarantee, so to speak, right? And that has been the key. In fact, I'll just share on this example of the resolution. I was very pleasantly surprised, surprised in a very good way, working with one of our key customers, where when they go from dev to production, when they promote a pipeline or a job, or basically a query to run in production, they actually have gatekeeping over there. And what the gatekeeping does is, and this is where they actually use Unravel, is that, given Unravel has recommendations, because Unravel is deeply analyzing, it's gathering, analyzing, and then making recommendations. They look for, are there recommendations that Unravel has specifically for this job they're about to promote in production? And they have had tremendous success in avoiding so many disasters, all the way from queries that were not written in a scalable way. Like, a classic example is out of memory. It's just unbelievable how many times I've seen out of memory issues. It runs, other day it runs into out of memory. That's because of data skews, because of pipeline delays. Apparently, if the number of rows goes beyond, and these are all hallmarks of a poorly written, I would say, pipeline or poorly written query. These things break from a fragility standpoint. So, number one, I would say, issue that I've seen most often is really the fragility, and the solution has been, have a proper step. And I cited this example, but just by going through that, I would say, gatekeeping. And it's interesting. We think of this as going back to software analogies, right? It's like you never merge code and deploy unless you have verified it. So how do you do that for a query? Obviously, there is the correctness verification, smoke testing, generating the right result. But will it actually work correctly in production? Is it tuned properly? Am I giving it the right? Am I just focusing on defaults, or am I giving the right number of vCores, memory, and so on? So yeah, I would say that is the way to really get ahead of this and have make this as seamless for all the teams involved. It quickly becomes a finger pointing game, and not very useful.
Okay, yes. Now I'm going to ask you two questions that come up, and I'm going to tell you what they both are in case there's interrelationships, and so you can time the answers. And then if we don't get any more questions, we'll finish up. And the two topics are basically SQL versus NoSQL and cloud versus on-prem. So for SQL versus NoSQL, literally, I mean, half a century of work has gone into optimizing SQL. And because SQL is pretty standardized, there are always exceptions. Some of that work has been academic or independent of any specific company or their version of SQL. So how much of an advantage do SQL queries have over non-SQL queries, and how can you split that difference? How can you get some of the benefits of SQL type performance for object stores and so on?
Yeah, that's a great question, Floyd. So firstly, before I specifically answer that question, just to clarify, when we, the SQL versus NoSQL started really as a movement, right, several years back. And contrary to the name NoSQL, what it really meant is that the kind of ACID properties that a typical relational system had, right, by compromising those properties, and this is where Eric Brewer's classic CAP theorem, or CAP, consistency, availability, and partition tolerance, comes in, which was roughly interpreted as pick two of three, right? So if you're doing consistency and partition tolerance, you will give up availability, or if you go availability and partition tolerance, then you will give up consistency. Which is actually a nice, again, it's simplistic. It's not a black and white pick two of three, but it's a good way to understand, right? Now, that said, if you really think about what is required by organizations, you need polyglot persistence. So what happened in the past is, in a relational world, you convert everything and try to represent it as a relational data structure, right? Now, not all data actually falls, and this is where years and years of work have gone, not just in representing, right, from the 70s, where the relational model was first invested in IBM research, right, in the database team, where we then started talking about normal forms and so on. But really, what has happened is that we have realized there are very different kinds of data that needs to be persisted. It could be a key value store, it could be a document, it could basically be a graph, right? So this new NoSQL can really be thought of really as building out your polyglot persistence, that is based on your needs, picking the right, I would say, abstraction layer. So if you're trying to store key value data, right, this is where you would use a key value data store. If you're looking at, if your data naturally can be represented as graphs, and this is where you see a lot of interest today in graph databases, because a lot of the relational data actually was better suited to be represented as graphs for both analytical queries and transactional queries. So I think going back, it is really the combination that needs to be leveraged. One caution I would provide based on experience is that there is a typical syndrome of picking the fancy technologies out there, right? And oftentimes I have seen polyglot for the sake of polyglot, which is there was really no need. And what that basically is that there's very limited expertise among the folks in terms of how to leverage that I would say that operational layer, right? How to best leverage a key value store, for instance, and so on. Especially when you think about specific kinds of APIs and SQL that some of these stores come with. So I think first, use it if you need it, which again, and this is where good design principles come in, right? Second, most applications will need polyglot if you're thinking of extensible, scalable. It really helps to build more services. And the key then in that case is to really think about it as query engines that can help you support these systems. So instead of trying to think about, okay, Cassandra operates in a specific way, MongoDB or DynamoDB, they operate in a specific way when it comes to documents, right? The idea would be, can you leverage generic query engines to then use these data stores under the covers, right? And I think that is the key that kind of plays in this space.
So,
yeah.
the old saying being that there's no problem in computing that can't be solved by another level of abstraction, right?
That that is correct. Absolutely, yes, yes.
A question just came in as we were speaking. What process is followed for gatekeeping? Do we have to test before production?
So typically you would follow the same set of things. Like gatekeeping, obviously you will have to test before production, right? But the key thing with gatekeeping is having a clear process which looks at, is this query scalable? Is this query something that will survive in production? Um, so that is the part of gatekeeping. When you're going to do the analysis, and the example I was giving, either use a tool or use human expertise, one way or the other. But definitely having a dedicated step where you can then push back, because this is your best bet. Once it is in production, then it is firefighting and the kind of nightmare examples I was sharing earlier. So hopefully that answers that question.
Yes. Okay. Yes, and for the questioner, if you have elaboration on that question, please get it right in, and we'll get on that too. For now, I'll think of the question as answered, and then let me focus on one last issue. I was going to ask generally about cloud versus on-prem, but instead let me fine tune that, especially with the Q&A we just had. The last box here is time to optimize cost. So the problem with the on-prem setup is you desperately wish you could scale it until you run a bad query, and then you're glad that all that happens is your cluster goes down and you don't spend $100,000 off of auto-scaling capabilities for a bad query. In the cloud, it might just auto-scale and answer your query and then send you that six-figure bill. Can you talk about specifically about the optimizing cost step on-prem and in the cloud?
Yeah, so optimizing, I think typically when you think of optimizing cost, auto-scaling is the first thing that comes to mind. And I'll say auto-scaling is the lowest hanging fruit in terms of the ability to really go down. And yes, if you're not using the resources, you scale the resources. Now, while in theory it appears nice, there are challenges. Auto-scaling is not instantaneous. There is often a lag from the time of need to the time required, right? So there is really that aspect. Like when I'm running, one can say, okay, I will auto scale completely on demand. Work that way, because 20-25 minutes to scale up the cluster. There might be some queries which are will be impacted. So part one is modeling doesn't go away just because you're using auto scaling. And the second part with cost is it's more than auto scaling. I'll give you an example. Instance types. What is the right instance type to run this query, right? I mean, there are tremendous number of instance types today that each cloud provider provides. And this is another example, and again, just to map it back, right, in the kind of optimization that Unravel provides. Unravel actually provides those recommendations based on detailed analysis, picks up the instance types, and will say that, okay, this is the right instance type to meet your SLA. So again, cost is a deep topic. Hopefully, I know we're running short on time, so hopefully that did give the high level bit of the answer.
I'll just mention that some of Unravel's customers, and this could be done with other technologies or approaches too. It's not specific to us, but something that people use Unravel for is they're now having developers try their jobs and characterize them before submitting their code to production, and that gives people a chance to understand which are some of the riskier possible workloads and what to keep an eye on, what to manage. So some things get, for instance, some jobs now get segregated off into their own dedicated cluster. Others get reworked before they go into production, just to manage this before the thing explodes on you and causes you a bunch of trouble. You get a warning at least of what jobs to keep an eye on. Is that a fair characterization of how people are using our software and
Yep.
maybe using your approaches too?
Yeah, absolutely. You summarized it quite well.
Okay, great. Okay, guys, we're nearing the end of the hour, and in this era of constant Zoom calls one after another, it can often be quite valuable to get a few minutes back. So we're going to wrap up, and thank you everyone for participating in this webinar today and in the entire series. They're all available on Bright Talk. We're talking about doing some kind of a summary or lessons learned in the future, but for now, this set of four webinars covers the book very well. Please share them with people who need them, which is the entire world of people working on this kind of thing, at least to give you all a lingua franca, to share among yourselves and be speaking the same language, working from the same framework as you tackle the many issues that come up and make your organizations work better, stronger, and faster. So thanks very much, and we'll look forward to meeting you in the future here on Bright Talk.
Yeah, and thanks everyone. And obviously, we continue to add and share insights. Watch out the Unravel blog as well as my Medium blog. You can follow me on Medium for continued insights as this space evolves. Thanks everyone.
Thank you. Bye-bye.
Bye.